Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's Techstrong Learning Experience, brought to you by AWS and PagerDuty. My name is Cody, and I'm the host of Techstrong Learning. We've got an exciting program ahead. Before we begin, I do have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, perhaps you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you want to interact with our speaker today, you can do so using the options on the right side of the screen. You'll notice there's a chat tab. I'd like you to start warming that up for us right now by letting us know from where you are tuning in. Right next to that chat tab, you'll see there's a Q&A portion, and that's where we would like you to direct your questions for today. We do have a poll that we'll be launching, so we do want your participation there. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program. So our topic today is noise reduction and auto-remediation with AWS and PagerDuty AIOps. I'm joined today by Frank Emery, Principal Product Manager at PagerDuty. Frank, thank you so much for being here with me today. Would you like to go ahead and get this kicked off?
Yeah, definitely. Thanks for having me. As was mentioned, we're going to talk about noise reduction and auto-remediation, and specifically, we're going to focus on how working with AWS and PagerDuty can make these problems really easy to solve. As mentioned, my name is Frank. I'm a product manager here at PagerDuty. Specifically, I work with all things AIOps and work directly with our event orchestration products as well. So to frame things up, the problem that we always like to focus on when we look at noise reduction and automation is really this issue of increasing event volumes. What we notice is that event volumes are increasing at 70% every year, and this is actually held constant the last couple of years. So this is not a new problem, and it's a problem that's getting worse. And the issue is, because it's a 70% growth rate every year, this is becoming exponentially worse. As more events come in, they compound the problems that teams used to see in the past, and that can make it really difficult to get ahead and tackle noise reduction in your system. With PagerDuty, we've noticed 3 big problems stemming from these event volumes. First, as those event volumes increase, teams are getting inundated by noise. What this means is, if you've gone from, say, 10 events to 100 or 1,000 events, now you're getting more incidents, more alerts, and your phone tends to ring off the hook. It's not uncommon for us to hear folks who have an incident, and while they're trying to resolve issues, they'll be acknowledging incidents as they're dealing with the incident that's already been created. This can be a huge distraction for responders and can really hurt productivity and focus. Additionally, as we see these event volumes grow, it can be more and more difficult to figure out exactly where and what happened when an incident is created. You can imagine if you have 3 or 4 or 5 incidents being generated, all of them with alerts and events, when trying to figure out exactly what failed, you have to go through even more data than you'd have to in the past, and that can be time consuming. Alternatively, you can spend a lot of time trying to figure out, is this actually your incident, or does it belong to another team at your organization? All of that is going to slow your teams down, and it's going to make it take longer to get production back online. Finally, what we're finding is, as these event volumes increase, teams are spending more and more time on manual tasks. With each event that's created, even if it only takes a couple of seconds to resolve, those seconds can add up to minutes, hours, weeks, and months over time. Imagine if every single event just took a couple of clicks to ignore, but you had 1,000 of them. That's thousands of clicks to now get rid of this work that's well understood and keeping your teams from stopping production from getting back online. Fortunately, for those of you who use AWS, PagerDuty has 14 out-of-the-box integrations that make this push button easy to solve. Fortunately, for folks on this call, if you're using AWS, PagerDuty comes with 14 out-of-the-box integrations to get all of these events into PagerDuty and start helping solve these problems right away. Additionally, you're able to send events to PagerDuty from a global integration that's able to infer which AWS tools you're using and automatically convert it into an event that can be used in PagerDuty. And once those events are ingested, dealing with all of those incidents I just talked about is push-button easy. We have a lot of tools in place to help you with everything from incident response to event management to automating resolution. So to get started and to have an idea about exactly how to start tackling these problems in your own systems, we like to focus on this maturity model to help customers understand exactly where they are, on their AIOps maturity journey and what tools are going to be useful for them at each step. To start, we like to think of the manual part of this. So these are customers or users who are very early in the process, and for them, what's really important is just getting events into their monitoring tool, into PagerDuty. And so really what we're focusing on here is ingesting events and adding the basic sorts of rules that are going to help those events become incidents in a meaningful way. This can either be ingesting events directly into a service, directly into a global integration, or using one of those out-of-the-box integrations that I mentioned. Once you've gotten past that manual step, the next step is reactive. This is where teams are already getting incidents into their system, and they want to start leveraging our noise reduction techniques to help make sure that those incidents are all valuable. So this can either be done through deduplication, grouping, or suppression, but really the goal here is to make sure that if an event is being ingested, it's being turned into a valuable signal. This can be a really important step for people in their maturity journey, because if you have too much noise in your system, you don't actually have enough time to deal with all of the other things that are going to help you and your team get back on track. Next in this journey is the responsive phase. Once you hit this phase, you have events entering your system, you're making sure they turn into valuable signals, and now you're focusing on leveraging the data in those signals to help expedite root cause analysis. Really what we're doing here is we're looking at the contextual information provided for all of these events and incidents in your system, and using that to drive powerful machine learning models that'll help figure out which incidents might be related, which incidents might have occurred in the past, whether or not something's an anomaly or not. And really the goal here is to accelerate triage. So using all of that high value data that you now ingested, using those critical signals you've made, and then turning those into useful triage insights to help get production back online. Next, we get into the proactive phase. This is where you've started to identify common patterns in your events and your incidents, and are starting to make rules to help accelerate remediation of those as soon as they come in. What's nice about the proactive stage is once you're here, you can really start to leverage a lot of the tribal knowledge that your teams have to start to really speed up incident response and address some of those manual tasks that we talked about earlier. Specific things you can do in this are making rules that specifically target different scenarios and using those to initiate things like automated diagnostics. Finally, we have the preventative stage. This is where you have enough information to really predict when an incident is going to happen and plan proactively. A great example of something from this stage is if you've done a post-mortem and identified that typically major outages are preceded by a certain kind of event or incident, you can make rules to automatically start a remediation before that incident even starts to occur. And we'll walk through a little bit later about how easy that can be for your teams to do. So with that overview of a maturity model, I want to take some time to stop and ask this group, if you had to place your organization on the operational maturity model, where would you think you are? We'll give people a couple of seconds to answer that and see where everyone's sitting. Interesting. That's awesome. It looks like the majority of people are in the reactive and proactive stage. That's awesome. So that means that you're really starting to tackle these incidents before they become major issues. And we'll actually have some really cool tools we can talk about later on about exactly what reactive and proactive looks like. Yeah, that's great. Reactive is great. So with that in mind, let's go ahead and take a look at how you can crawl, walk, and run towards adopting some of these different solutions to event volume and automation within your own systems. So to start, we want to look at crawling towards noise reduction. Features in this part of the AIOps tooling really focus on helping people in that initial sort of manual phase of the maturity model. And really what we're focusing on here is getting events ingested and then giving people the tools they need to start reducing noise in their systems. I mentioned earlier that if you have too much noise in your system, it can be very difficult to actually adopt more mature AIOps strategies because you're always kind of catching up to things. And so what we like to look at here is noise reduction techniques and identifying common sources of noise in your system. Once you've identified those, dealing with them and making sure that only critical incidents are created is going to give responders time back. It's going to decrease their cognitive load whenever an incident comes in. And it's going to make sure that they can focus on what matters, which is going to reduce on-call anxiety and make sure that they're focusing on what's important. So in terms of noise reduction, this is sort of an idea of where that would live within the existing PagerDuty AIOps lifecycle. So in general, this is what the incident lifecycle looks like at PagerDuty. And all of our noise reduction features are sort of at the front. And we have three that come up. To start with, whenever an event is ingested, the first form of noise reduction that we use is what's called deduplication. Typically, deduplication is used to control our triggering, acknowledging, and resolving process. However, sometimes multiple trigger events will be sent into PagerDuty, and that can be a big source of noise. What that would mean is every single time an event gets triggered, you're getting an incident that'll look the exact same as another incident that's occurred. With deduplication, what will happen is all of these same sorts of incidents with the same deduplication keys will get combined together, with each new event being deduplicated, updating the information in the existing incident. What's kind of nice about this is as each event is deduplicated, you're basically giving an existing incident fresh information about what's happening in your system. Afterwards, the next level of noise reduction that a user can implement is what's called suppression. Suppression is where you make a rule that specifically targets a kind of event, alert, or incident, and stops that event from actually generating a notification. Users will still have access to alerts that are suppressed within their system, so they can still use that information to do diagnostics and triage. However, no responders are going to get notified. Finally, we have our biggest noise reduction feature, which is around alert grouping. And there's kind of two options for using alert grouping. One is via content-based alert grouping, where specific rules are made and allow you to target specific kinds of events to group together. The other is our machine learning-based solution that allows users to use machine learning to automatically detect incidents that might be the same and combine them together. Where multiple events have been grouped together using this tool, all of their alerts will show up in the alerts tab, so you kind of have an idea of which events are being pulled together over time. With that, I'm going to go ahead and have a quick demo of what this would look like. So to start, what I'm going to do is I'm going to make sure that I have event orchestration set up to start doing some basic noise reduction with suppression. As you can see here, I already have an AWS CloudWatch alert integration in place. And so I'm going to go ahead and use this integration and make sure that I'm sending events to the correct team. Here we can see I have an existing event routing rule that is taking all of the events from this integration and sending it to my AWS team. With that in place, what I can then do is go to this team and set up some orchestration rules that are going to automatically start suppressing noise for me. To do that, I'm going to hit New Rule. I'm going to look over here. I'm going to see which of these tends to be a big problem. Expanding all of these alerts, I can see the different sorts of issues happening in my system, and I can get an idea of what different scenarios I can start to suppress noise with. I think the first thing I'm going to target is these warning alerts. Typically, warning alerts can be useful for teams to understand, but you don't necessarily want to have an incident trigger for them. Clicking that warning field, I've automatically created my condition for this rule. I'm going to hit Next. I'm going to suppress. Saving that, I'm now being able to suppress all of those warning events across this service, stopping them from generating notifications. Functionality like this can be a great tool for implementing noise reduction in your system, with some customers being able to reduce up to 80% of the noise that they experience in just a couple of minutes by identifying noisy events and suppressing them right away. Next, what I want to do is make sure that I'm leveraging alert grouping. Clicking this up here, I can navigate directly to the service, and then from there, go to the Settings tab to look at some of the noise reduction functionality. Hitting Edit, I can see all the different options available. I'm going to go ahead and select Intelligent Alert Grouping, which is going to automatically start grouping alerts that match our machine learning algorithms' interpretation of what is going to be similar and needs to be grouped together. This machine learning algorithm is automatically trained. There's no data scientist intervention required, and will adapt based on individual user interactions with incidents. So If incidents are grouped when they shouldn't be, you can unmerge them and the model will learn. Or you can merge incidents that weren't grouped, and again, the model will adapt to that. Additionally, I'm going to go ahead and activate my auto-pause transient alert functionality. What this is going to do is automatically detect incidents in my system that commonly self-resolve after a couple of minutes, and it's going to make sure that no notifications go out for that before they have a chance to self-resolve. What this means is that a lot of the incidents that be distracting developers, by the time they get to the computer, only to see incidents be resolved, will have that ability to resolve themselves before notification is sent out. Being safe, I can now be confident that this AWS service is going to be well configured to help support noise reduction. I'm just going to take a stop there for a second and look to see if there's any questions. It doesn't look like there are, but if at any point you have questions or you want me to go into more detail on anything, please feel free to post in the chat, and I'd be happy to take some time to answer those. Next, we're going to go ahead and look at how we walk towards data enrichment and improved triage. So now that we've gotten all of the incidents into our system and we're making sure that we're only focusing on critical things, the next step is making sure that we're resolving these critical issues as quickly as possible. As I mentioned earlier, with a large volume of events, it can be sometimes very distracting and difficult to figure out exactly what caused an incident. And fortunately, what we've done is loaded into PagerDuty AIOps a series of machine learning models that are specifically designed to help solve this problem. And really, the way that we look at the situation is with the 5 questions listed here. When an incident's created, where should teams look first? Are other teams working on the same problem? Is it a common incident, or is it completely new? Have we seen this before, and how was it resolved? And are there any relevant changes before the incident occurred? By answering these questions, responders can quickly figure out exactly why an incident occurred and how to start fixing it immediately, instead of having to wait and research more information. The nice thing about all of these triage features is they're self-training. There's nothing you need to do beyond having incidents go into a service, and then over time, this information will be generated for them, giving responders the ability to start triaging and solving incidents faster. Going back to that lifecycle screen again, all of these triage features live in the human response part of the incident lifecycle. That's because these features focus on incidents that have been created. Once that critical incident is on a responder's plate, we want to make sure that those humans have the tools they need in order to start resolving things right away. And we have 5 of these tools built into the product right now. The first is probable origin. Probable origin is able to detect the likely origin of an incident within your system. It can look at all of the other incidents that have occurred across every other service and team and dynamically predict what other incidents that have occurred recently that might have caused the incident the responder is currently looking at. We have another feature called outlier incident. This allows responders to quickly understand if an incident they're looking at is novel and new, or if it's something that's happened in the past, giving them the ability to either dedicate resources towards looking for a past solution or figuring out what might be new with this situation. Additionally, we have something called similar incidents. What this allows you to do is look at other incidents occurring across your company that might be related to the incident that you're looking at now. This can sometimes be useful if you think that the incident you're dealing with was caused by other teams or could be related to a larger issue at your company. Additionally, we have past incidents. This will pull up all of the past incidents that have occurred that are similar to the ones you're looking at now, so you can review them to see how past responders resolved them. And then finally, with our change events integration, we're able to pull in any changes that occurred for your service immediately before this incident occurred that might be related to this incident. What we often find is a recent change is often the cause of a current failure. So being able to review all of your current change events in one spot can really help speed up resolution. So with that, we're going to go ahead and take a look at another demo. So what I'm going to do is I'm going to go ahead and navigate to a service that I know has had some interesting incidents in the past. Specifically, my checkout API service. So I know that there was an incident that occurred recently, famous incident number 197 that occurred on the 21st, where responders struggled a little bit. And so what I'm going to do is walk through all of the triage features that exist for this particular incident that could have helped the responders deal with this issue faster. For starters, looking at this page, we can immediately see this is an anomalous incident. It doesn't happen very often in our system, And so we know that we're in for a bit of a difficult resolution here. Scrolling down the page, I can see that some recent changes were made, specifically to the config and code deploy process. It's good to know if a recent change went in, as I mentioned, a recent change can often precede a failure. Looking at related incidents, I can see that there was one other incident that occurred at the same time as this, specifically on the checkout infrastructure service, and I can see here that the checkout API that I'm looking at now leverages that service. So it could be that these two incidents are related, and there might be someone in that team who I can talk to for help. Finally, I can see that this incident has occurred in the past. It's actually occurred 5 times. Particularly, there was a lot of occurrences in January. I can see here the different incidents, and can link out to those different pages to see how that incident was resolved. Let's take a look and see if any of these were useful. Navigating to the first one, I can see that this incident is in fact helpful. So there was actually a resolution note that was very helpfully left from the last person who took a look at this, who actually does mention there was probably that deployment that caused my past outage. And if I roll that back, it'll likely be the fastest way to get production back online. That's always good news. So I can come back here, I can take a look at these, and I can figure out which of these to roll back. With that now diagnosed, and hopefully next time solved a little bit faster, we can actually work on the next stage of our maturity model and getting AIOps deployed. But again, I want to take a moment to stop and see if there's any questions. There's a couple of questions, it looks like, in the chat. I see there's a question asking if it is in beta mode. Is that the screen or a feature? There's another question that says, intelligent alert grouping preview data is not available. No intelligent alert grouping preview data is available for the service. Previews are generated daily using alerts from the past 45 days. Yeah, so the preview functionality within PagerDuty will get populated once a sufficient number of incidents have been sent to a service that are capable for grouping. So what will happen is, as more incidents are sent into your system, our grouping logic will basically look at how those alerts would have been grouped in the past if alert grouping was turned on, and then it'll automatically populate that preview feature. If you're not seeing any previews populating right now, it could mean that there haven't been enough incidents in recent memory to trigger the grouping, or that there weren't any groupable incidents recently. My suggestion in this case is the more the service gets used and the more incidents are created, the more likely you'll start to see some preview data there. I see another question asks, does PagerDuty use logs? That is a good question. So PagerDuty is not a logging tool itself. However, you can send a variety of different events into PagerDuty. We have somewhere between, I want to say, 600 and 700 different integrations. And so dependent on the tooling you're using, it's entirely possible there's either an integration for it, or you can use a global integration to get that data into PagerDuty. Hopefully that answers your question. So with that in mind, let's move on to the final stage of our crawl, walk, and run approach to adopting AIOps with AWS. And that is what many people consider the most scary and difficult to implement phase, and that is running with self-healing and auto-remediation. A lot of people will look at self-healing and auto-remediation, or automation in general with respect to incident response, as sort of a scary, lofty, difficult to implement tooling. What we've tried to do with PagerDuty AIOps is make this as easy to implement as possible. And what I'll also say is, people don't always realize, but implementing automation is a lot easier than you would think. There's a lot more that counts as automation than people would think. A really good example that I like to talk about is, if you have a really common issue that you keep on seeing come up over and over again, automation could be as easy as adding a note telling the responder exactly how to solve it next time they see it come up. Automation could be enriching an event so that it is created as an incident with all the data necessary to help a responder solve it right away. Automation can be routing as well. It really kind of depends on the different sorts of situations that your team is trying to implement. And so what my advice would be is to anyone trying to adopt self-healing, auto-remediation, or automation as part of their incident response process is keep an open mind and really look for where your teams are wasting a lot of manual time and whether or not you can automate those processes. Because there are a lot of options that people can implement. What I'm specifically going to walk through today is really our automation actions and webhook features and how they can do in diagnostics, but also walk through some of those more easy to implement examples as well. And so going back to that life cycle of an incident, what we're really looking at now is our event orchestration and machine response features. With event orchestration, what you can do is you can develop complex if-then logic that acts as a decision engine within your event ingestion pipeline, which is able to automatically respond to and take action on different kinds of events based on different sorts of rules that you've made. Within each of those rules, you can also embed the ability to automatically execute machine responses so that as soon as an event is ingested, you can start acting on them right away. The two kinds of machine response that we support are a direct integration into automation actions, as well as webhooks that can be triggered, which are most frequently used with Rundeck. What I'll do now is I'll show you a quick demo of how to implement all of this within your system. So to start, what I'm going to do is I'm going to navigate to automation, go to event orchestration, and I'm going to go back to that AWS CloudWatch alerts screen. I'm going to navigate to my service orchestration for AWS, and I'm going to go ahead and start building out my automation. To start with, I'm going to create a new rule to target a common incident that has made a lot of noise for my team in the past. This high CPU utilization issue has been kind of a pain for my team. It can create a lot of noise and not necessarily add a lot of value. And so I'm going to go ahead and make a rule, excuse me, that's going to help start controlling that noise a little bit and helping trigger automation in a safe fashion. So to start, I can see here that the threshold for my CPU utilization is 80%. So what I want to do is I want to say if my utilization is over 80%, which I've done here using PCL, then I want to go ahead and pause notifications for about 5 minutes. What my team has indicated is that in the past, whenever this incident comes in, usually CPU utilization will come back down on its own. And so by pausing this event, we're giving this incident time to potentially self-heal beforehand. But I'm going to leave a note for my team to let them know what I've done here. So I'm going to say this incident has been paused for minutes. I'm being fairly optimistic. Hopefully this fixes the issue. I'm going to go ahead and hit save, and then I'm going to create a nested rule underneath. For this rule, I'm actually not going to add any conditions. And the reason why is if that suspension ends up being exceeded, so an incident is created after 5 minutes, what's going to happen is the incident that is created will start to adopt the fields and functionality defined in this nested rule. And so in the situation where this incident is actually created, I want to make sure that my team knows it's a P1. This incident did not self-heal. So it's a big deal. I'm going to make sure that it's critical. And then what I'm also going to do is I'm going to go ahead and trigger a webhook to try and restart this server. So in the past, restarting has sort of fixed this issue. And so I'm going to say automatically trigger a webhook for my AWS priority action plan. What this is going to do is as soon as the incident is created, it's going to fire a webhook. It's going to execute a Rundeck job to try and fix this issue before a responder gets to their computer. So hopefully the responder isn't dealing with an issue. It's been solved already. Clicking on this, it'll summarize all of my information for me. And then what I'm going to do next is deal with another use case that my team has been struggling with. And that's specifically the issue with my RDS instances. So again, I can see here that there's a threshold in place. And so what I'm going to say is, if the threshold is over 500, so in the instance where I've reached the threshold, what I want to do is go ahead and trigger a process automation job. So for this particular incident, I know that oftentimes once a threshold is breached, there could be a lot of different things contributing to what's going on. I want to make sure that my responders, when they log into PagerDuty, are presented with an incident that has diagnostics information available for them to start dealing with right away. So I can see here I have a couple of options. I'm going to go ahead and select the AWS integration. And I add a note in here as well saying an automation action job is being kicked off to get diagnostics. I'm going to go ahead and save. And now whenever this incident is created, it's going to automatically initiate that automation action job. And again, hopefully load this incident with the diagnostic information that my responders need in order to start fixing things right away. So with just a few button clicks, I've been able to implement automation, self-healing, and auto-remediation across my entire system fairly easily. Earlier, I did mention I was going to give an example of one of the more easier to approach automations that exist in our system, and I'll walk through what that looks like now. So one of the easier automations that you can also implement is around transformations. Transformations are powerful tools that allow you to rewrite and automate the population of incident fields by event data during the ingestion process. Using this, what you can do is you can automatically rewrite a variety of fields so that when an incident is created, your teams have the information embedded in the incident object to start solving problems right away. This is a really easy way to start with automation inside your systems, and it's especially useful if you want to standardize what all of your events and incidents look like, or provide information to responders immediately around what sorts of diagnostic steps and remediation steps they should be taking. To populate this, you can select any field and either construct fields using regex or reference fields directly within a raw event payload to reconstruct an incident from scratch. I'm going to close that so my responders don't have to worry. And with that, as I mentioned, I have set up automation. So that is all of the stuff I wanted to cover today. And I wanted to pass things over to the group to see if there are any questions that people had or anything that folks wanted me to go into more detail on. We have a 7-second rule at PagerDuty where I wait 7 seconds to see if anyone has a question that they want covered.
Hey, Frank, it looks like we got one in the Q&A, so they might start rolling in right about now. Awesome.
Cool. So I see there's two now. This is excellent. That's why we have the 7-second rule to give everyone time. For organizations who are having a tough time getting buy-in for automation, what would you suggest? This is a great question. What I find works really well for getting buy-in with automation is focusing on a couple of really tangible and easy to implement use cases. So usually when people think of automation, they see it as this really daunting, expensive, time-consuming thing to implement. But as I mentioned, automation can be, as small as triggering a webhook or just automating event enrichment. So my suggestion would be look through all of your current incidents and try and figure out what's been generating the most noise for your team, the most manual work, and then figuring out how that can be automated in a really low-code, easy-to-implement way so that you can sort of show the value of automation and get incremental investment from there. What I've seen a lot of other users do is say, implement a webhook that kicks off a run-dev job or hits AWS Lambda and initiates some sort of basic trigger that's going to help you take some load off your responders for a well-understood process. So that'd be my recommendation. How do you handle different date formats and logs? That's an interesting one. So there's kind of a couple of options for this. If you were doing direct integration using one of our sort of out-of-the-box integrations, what'll happen is that out-of-the-box integration will specifically define how dates and actually all fields within an event payload will be transformed as they're ingested into PagerDuty. So that one's kind of the more straightforward one. If you send things in globally, what'll happen is we'll do our best to infer the event type, and then we'll transform date formats into what's called a common event format at PagerDuty, which is basically a standardized event representation. So that date format will be into the standardized PagerDuty format. However, that original raw event payload that occurred pre-transformation will still be available to you to write rules against. So you'll either be able to reference original date formatting from whatever tool was integrated with PagerDuty, or the standardized date formatting that exists as a result of our event transformations.
Well, Frank, while we give our audience just a few more seconds to send in any more questions they may have, I'm going to go ahead and just make some announcements. So if you happen to miss any of our program, maybe you joined us late, perhaps you'd like to rewatch, or of course, if you'd like to share this with a friend, you will be receiving an email with a link to access the recording on demand. And you can find the recording for today's program living on the DevOps website at devops.com/webinars.
And there's another fantastic question that came in. When we talk to customers, is there one stage between crawl, walk, or run that seems to be the hardest? We're stuck at walk right now. How do they overcome? This is actually a great question. This comes up a lot. I would say walk can be the hardest. For some large users, walk can be very difficult, especially in terms of how you manage your event data. Once you've sort of gotten past the walk stage, especially when it comes to these events within PagerDuty, you tend to be able to rapidly progress to future stages. The reason why walk can be very difficult is because it can be very overwhelming to get all of your events into PagerDuty. It can be very overwhelming to structure rules around them, to create processes around them. And so previous to what I said, if you're still struggling with getting events in and getting noise reduction in place, you're never going to have the time to do any of these other tools. And so I think that's where a lot of people struggle. My suggestion would be, with PagerDuty, there are a couple of tools that make it really, really easy to progress once events are in. So step one is really getting your events into PagerDuty, and then once they're in, leveraging some of our tooling to really rapidly address them would be my suggestion. And as an example, I was working with a fairly large user. They were sending us sort of millions of events. And with just a handful of event orchestration rules, they got 80% noise reduction. With just a handful of alert grouping configurations in place, then got that to 90% or more. And so really, once those events are in, you do have those tools to really rapidly get a handle on your data. The other thing I'd say really helps is normalizing your event data. So if you do find you're working with a lot of different monitoring tools and it can be difficult to progress because you're sort of standardizing and normalizing data across them, with just a handful of event orchestration rules, you can normalize all that data, which makes everything else easier downstream. If you're dealing with consistent incident formats, it can make everything a lot easier. It's kind of like everyone's talking the same language. So it sort of breaks down some of those barriers.
Well, Frank, seeing no more questions, is there anything that you'd like to let our audience know, or any final remarks before we close out?
Yeah, I mean, and I mentioned it earlier, my suggestion would just be that, once events are in PagerDuty, a lot of this stuff can be easier to implement than it looks. And so I would say, don't get scared off. Get your events in, and then there's tooling in place to help you tackle some of these problems. I know my team uses AWS CloudWatch for one of their integrations. We get a lot of event data coming in. And for us, the first part of the battle was just using some of these tools to get a handle on things early on so that we can get time back to mature models over time. So yeah, just get your events in and then use some of these tools to, get a handle on things now.
All right. Well, Frank, I really appreciate your time, both today on the air and in our call prior, and all the time that it takes, of course, to put together the demo and your presentation. So thank you so much for your dedication.
Awesome. Thank you for having me.
Happy to have you. We did receive one more question. Is PagerDuty an app in the AWS marketplace?
I believe it is. I'm 90% sure it can be purchased from. I'm 97% sure it can be purchased from AWS Marketplace.
Awesome. Awesome. Well, Frank, thank you so much for sticking around and answering that question too.
Awesome. Cool.
I'd like to announce our 4 winners of our $25 Amazon gift card giveaway. They are Dana C, Eden T, Sajid A, and Tyler N. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. Should make its way over to you in about 48 hours. If you don't happen to see that email, please check your spam folder just in case it gets filtered out. I'd like to thank PagerDuty and AWS for sponsoring our program today. And to everyone who joined us, thank you so much for being here. We really value your time and we want to hear your feedback. As soon as we close out, there will be a survey. Please let us know your thoughts on our program today, or perhaps what you'd like to see on an upcoming program. Regardless, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and Frank, thank you once again.